Welcome back to the channel, guys. So let's continue solving our DSA level sheet. So up till now we have solved 15 merge intervals. Okay. So next problem is next permutations. Let's see what does the problem say. The problem says implement the next permutation, which rearranges the list of numbers into lexicographically next greater permutation of list of numbers. If such arrangement is not possible, it must be rearranged so to the lowest possible order, that is sorted in an ascending order. You are given a list of numbers ARR of size n. Okay, let's understand what does the problem say. So, so let's suppose we have an array 3, 2, 1. Now, for the audience who doesn't know what is the meaning of permutation, permutation is arrangement. Like, in how many ways can this number be arranged? It can be arranged like 1, 2, 3. Another possible arrangement is 1, 3, 2. Then comes 2, 1, 3. After that, 2, 3, 1. After that, 3, 1, 2. And after that, 3, 2, 1. Am I correct? So, for the sequence of length n, what are the number of permutations possible? N factorial. It is simple maths. This formula is of no need to us right now. What we have to focus is, like suppose we have been given 3 to 1 as an input. Okay. We have been asked what is the next permutation, that is the permutation if this list is arranged in a sorted order, then what is the next permutation, what would have come here. Okay, so there are two cases. Suppose now the permutations are p1, p2, p3 and up to pn. So suppose we have been given p2 and asked the next permutation of p2. In that case the answer would be p3. Okay, but what if we have been given pn? After that, nothing is present. Where should we go? So in that case, we have to return P1. And what is P1? P1 is the smallest possible arrangement of elements in the array. Of elements in the array. Now, if I am been given A, B, C, D, E as an array, what is the smallest possible? Suppose we have been given a condition that A is less than B is less than C is less than D is less than E. So isn't a number arrangement A, comma B, comma C, comma D, comma E is the smallest possible? That is, suppose we have been given a number 1, 2, array 1, 2, 5, and 7. Isn't the 1, 2, 3, 5, 7 the smallest possible arrangement? Think about it. There is no explanation for it. You just have to think it. The smallest possible arrangement is the sorted order. Okay, smallest possible arrangement is sorted order. I hope I'm clear until now. So let's move on how to solve this problem. All right. Suppose let's consider the example given to us in the example statement also only. It has been given to us. No, the example statement is quite bland actually. Let me take you to an example that you might consider good. Suppose we have an array 2, 1, 5, 6, 3, 0, 0. This is the input array given to you. All right. Okay. I have to find the next permutation for it. Definition next permutation, I think you have understood that the number arrangement just greater. This is enough for you to remember. All right. So how can we proceed? The brute force solution that you all might have thought about right now is generate all permutations After that, linear search the arrangement you have been given as an input. And after that, give the next permutation. Isn't it obvious? Isn't it the brute force solution? Very straightforward. Generate all the permutations possible, and after that, use the next permutation. Linear search the permutation given to you in the array. Like of the given array, form all the permutations. Okay. In that array, in the data structure, you stored all the permutations. Search for it, which where 2156300 is present, and after that, return next permutation. That is the element present at the next index. The array present in the next index is your answer. Okay. So what will be the time complexity for this? For step one, for generating all the permutations, it would be O of n factorial into n. We know from the permutation video that the complexity for making all the permutations is n factorial into n. For linear search, we still have to search O of n factorial values because for a no, for n number of elements, O of n factorial number arrangements are possible. So we have to linear search the uh, data structure which size is O of n factorial, and then to return we just need to use one. So O of one only. So it would be O of n into n factorial. Okay, very high. Okay, very high. So it is inefficient. I have to use a better approach. What is the better approach? So the array given to us was 2, 1, 5, 6, 0, 0. No, this was not the array. Oh, sorry. I missed one element. The array given to us was 2, 1, 5, 6, 3, 0, 0. This was the array, right? Okay. How can we proceed? Now we have to find the next permutation. If I ask you to forget about the array once. Let's consider a small example. For example, you have been given an array 2, 1, 3. Let's try the brute force method for this one. Generate all the possible permutations and sort them. Okay. To sort them, we got after sorting, the permutations would be like 1, 2, 3, 1, 3, 2. After the second will come 2, 1, 3, then 2, 3, 1, then 3, 1, 2, then 3, 2, 1. I think I'm correct. Okay. Correct me in the comment section if I'm wrong somewhere. Okay. So 213 is given to us. And 231 is the answer, that is why. So if you observe 213 and 231, you see 2 is common here. I'm trying to draw inference here. Okay. Let's consider and Ram and Sham a problem. Okay. So in a dictionary, suppose you have to find a string A, B, C, F. Okay. So, and you have been given two position of two strings, that is A, B, C, D, and A, D, C, F, and also one more string A, C, E. So, if you have been given position of string this one as X, this as Y, and this as Z, which one would you think that is closer to this? Closer. I am asking for closer. Okay. For closer, you will see the longest prefix match. Correct? You see that ABC is a match here. Now, if ABC is a match here, which is the longest length of the prefix match, so this should be the closest ones to the position here. So, if the answer of this is A, then A is closest to Y. Correct? I think you are getting my point. I'm saying that we have to make a string of longest prefix. Of longest prefix. What I'm saying is, I'm saying we have to find a string of longest prefix to find the arrangement. Okay, so the longest prefix can be first case, the whole string. But if I fix the longest prefix as a whole string, then the answer would be the same string. That is not possible. I will have to reduce the length. Let's go up till here. But if I fixed all these elements and I'm remaining with this element only, which with whom I can shuffle it because all other are fixed. So this is not also not possible. So again no, I have to come to here. So now these two elements are present. Now if I observe that 0 and 0, but these two elements are similar. If these are similar, the possible arrangements of these elements are 0, comma 0 only. But that would give the same string again. So this is also not possible. I will have to reduce the length further. Coming here. Now 300. The possible arrangement of the letters 300 is 003, 030, 300. Okay. So there can be a change in the string if we replace them. But is it possible to make a string greater? What I'm saying is the next permutation asks me to make a string which is greater than this. To make a string which is greater than the present string. But in the above sequence, if I put 003, the string obtained would be less than the input. Same is the case for 030. And the string 3, if I put 300, I will obtain the same string. So this is also discarded. Okay. So I will have to reduce length even more. I have to go up till here. Now 6300. Now if I observe the lowest possible arrangement of 6300 is 0036. Thus sorted order. And what would be the maximum order? It would be 6300. In the sequences present in the middle, for any of the sequence, it is not possible to generate a sequence greater than the input sequence by putting it. So I will have to discard this also. I have to reduce my length one again. Okay. So to reduce the length again, I go up till here. Now there is a catch. The possible string greater than it string arrangements from the given remaining letters are 00356 going up till 65300. Okay, so I have got some numbers that can, if fitted in the right order, can give me the sequence which is greater than the present sequence. So we have been given 56300. Okay. So to make a sequence just greater than this, I will have to arrange this 56300 such that we get a sequence greater than, but just greater. The word just here is very important. Just greater. Okay, because this is also greater, but this is not the immediate next. We have to find the immediate next permutation. So 56300. Okay. For 56300 to be greater, isn't it obvious that if 6300 was maximum in itself, so if 5 is here, we have to put an element greater than 5 here. So the in the remaining part, that is 6300, the only part greater than 5 is 6. I put 6 here. Now to save the time complexity, I swap the 5 and 6. So it 5 comes here, 300. Okay. Now 65300 is a permutation that is possible. But wait, is it the just next? No. If I observe in the given sequence 60035 is also a possible arrangement. And now if I observe the input and the output, this one is greater than input and this one is smaller than the largest one. So I think it is our answer. Okay. So we have achieved our answer. We have understood how we have done so. Now let's try to decrease the time complexity of how we are doing. So what we have done is, if you have observed, we were finding the longest prefix length. Okay. So our array was 2, 1, 5, 6, 3, 0, 0. We tried to find the breakpoint. If you observe, we tried to find a number 5 where we can put from where we can change the right string, the right subpart. How, if you have observed, is there something different about this number? Okay, let's observe. In the first one, when we are taking the full string as the longest prefix, that was not possible, right? So longest prefix equals to n, not possible. Longest prefix equals to n minus 1, not possible, because only one digit would have been left. Okay, longest string n minus 2 could have been possible if these two were different, so it is a possible sub choice. Okay, now n minus 3 would have been possible, but the arrangements from 300 is not does not give us anything just greater than it. It is the maximum possible. Why is it the maximum possible? Why is it the maximum possible? If you see, it is the maximum possible because the number 3 is maximum in this right subpart, and it is present on the most significant bit. You have heard the most significant bit and the least significant bit in bitwise operator. Now I'm talking about that only. Consider it as the most significant bit. So most significant bit is the highest part. Is highest in the right subpart. Not possible. Similarly for 6300. But in 56300, MSB is not the highest one. 6 is just greater. So how can I find uh, the breakpoint without using many time complexity? If you observe, if you plot the graph of 56300, you see 0 comes here, 0 comes here, 3 comes here, 6 comes here, and 5 come here. So the graph looks something like 0, 0, 3, 6, and then there is a dip. So I'm able to figure out that whenever there is a dip, breakpoint achieved. So what we have to do is start from this index, because this index cannot be the possible, because it would give rise to the n minus 1 case. Okay, that is not possible anytime. Start from this index. This index is n minus 2 and start traversing back. Okay, whenever you find array of I is less than array of I plus 1, observe that I'm not also putting equals to, it should be less than. Okay, less than array of I plus 1, breakpoint is ith index. What was the next step? We swapped 5 with 6. But why did we swap 5 with 6? What if there was a condition like 5, 8, 6, 0, 0? If the subarray would have looked like this, what would have we done? If 5 is the breakpoint here, so would we have swapped it with 8 or 6? Let's discuss. What would it, if would we would have swapped it with 8? 8, 5, 6, 0, 0. Now if you observe, and if what if we would have swapped like this? Now if you observe, both the sequences greater than this one, but this one is more closer. So this one can give us rise to the just next one. So we have to find the element in the right part traversing from this side that is just greater than this one. So what is the next step? Like it was an array 2, 1, 5, 6, 3, 0, 0. We found at this at I. Now we have to start traversing from this index because we have to find the element just greater. Okay, so we can try from the n minus 1 index, this index, and find an element just greater than 5. This is not greater than 5, this is not greater than 5, this is not greater than 5, but 6. Yes, 6 is greater than 5. So we find an element 6 greater than 5, and name it as j. And then we did, we swapped those. So we swap I and j. It becomes like 6, 5, 3, 0, 0. Okay. So now we got the 216 is fixed. Now we have to manipulate the remaining part to get our answer. Now since any sequence starting from 216 is greater than any sequence starting from 215, what I'm saying is 216 dot 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 is always greater than 215 dot dot dot. Simple decimal maths. Okay. So I have to find just next, just greater. This should be smallest arrangement. Okay. But we talked about it in the above slides. The smallest arrangement is sorted. I'm not repeating it. The smallest arrangement is sorted. Okay. Now, pay attention. What we did was the array was 2, 1, 5, 6, 3, 0, 0. The graph was something like 0, 0, 3, 6, then 5. Now, if this was the graph, the breakpoint was here. If I swap these up, the graph would be something like 0, 0, 3, 5, 6. So I am able to observe that if after swapping it becomes 5, 3, 0, 0. Okay. And I have to reach up till 0, 0, 5, 3. Are you able to see that here I have been seeing a decreasing order and here I have to see an increasing order. So isn't it that sorting here is equivalent to reversing? But reversal from where to where? From I plus 1th index up till n2. Just have a look. If 6 was here and 5 was here, so after 5 here, it would have become an in decreasing order. Instead, we want an increasing order. So to convert a decreasing to increasing, we just reverse. But reverse from I plus 1 because this was I plus 1 to end. Okay, I think I have made my point clear. Let's code it down real fast. It's a very easy problem if you understand it correctly. So what we have to do is take an index I, name it as n minus 2 because we have to start traversal from the n minus 2 index. While I is greater than or equals to 0, if ARRI is less than ARRI plus 1, break. What if I equals to minus 1? I forgot to discuss this method, this case. What if we have been given an array like 1, 2, 3, sorry, it isn't. The array like 5, 4, 3, 2, 1. This the case I'm talking about is, oh, I just removed it from here. The case I'm talking about is the last permutation. So the condition was ARRI just less than ARR of I plus 1. So the breakpoint was like this. Okay, this was our breakpoint. But the whole array is like this. If you see 1, 2, 3, 4, 5. Are you able to see any breakpoint? No. So what we have to do? If there is no breakpoint, that means the array is representing the last permutation. Array is representing last permutation. So what we have to return in sorted order. And as we discussed, to convert a decreasing order into the sorted order, just reverse it. Now in this case, what we have to reverse? We have to reverse the whole array, full array. Okay. So let's see how we have to code it. If I equals to -1, we have the last permutation in hand. So what we have to do? We have to reverse it. Reverse arr dot begin to arr dot end. This is a vector STL. I hope you know it. Else what we had to do? We had to find an index that was giving us array of j in j is equals to n-1 because we are starting from j, while j is greater than end. Is my inequality here correct? J should be greater than end or j should be greater than equal to 0? It should be greater than end, because if we have find the breakpoint, then there is an element which is greater than I. Okay, so we can go up till end. Oh, sorry, end is I here. Sorry for my mistake. Okay, j is greater than I. Okay, what we have to find? If array of I is less than array of j, break. Okay, array of I is less than array of j, then break. Okay, done. Now what? Now when we have got I in hand, the breakpoint, and j in hand, the next permutation hero. What we have to do? We have to swap these up. Swap ARRI with ARRJ. Okay, we have swapped. After that, what we have to do? Reverse from I plus 1 to end. Again, using the STL, we just use reverse from ARR dot begin. From where? From I plus 1 up till ARR dot end. After that, return our ARR and see the compilation results. Seeing the compilation results, hope it works. I have not committed any error. Oh, this is the case always. Error committed. Classic capitals mistake. Pray to God. No error, no other errors. Time limit exceeded. Okay. Oh, I've used a while loop here and I've not incremented or decremented them. Sorry guys. I should not have done that. Okay, it's working fine. The compile run. Let's try it to submit. Oh, 321 is giving an error. What error? Well, J 321 is given error. Okay. Why is it giving an error? I is equals to n minus 2. Okay. If abort signal says that I have somewhere used which I should not have used. Okay. Um, it should not have given this error. Just a minute, let me check. I is equals to n minus 2. I plus 1. 321 is given error, right? Okay, okay, okay. I have to return it from here only. Because for J it will not work, right? Sorry guys. Let's try and submit. Oh, sorry. Thank you for watching the video. Sorry for the delay in the between, right, while writing the code. Hope you have liked the video. Please don't forget to like and subscribe. Your subscription means a lot to me. See you in the next video while we solve the next question of a DSA level sheet. Keep struggling, keep hustling, and don't wait until you get into a farm company. All the best to you and your future endeavors.